Hello, Legacy Sabers, Marsh here. So today we're going to talk about simplifying radicals. You want that foldable, it's a big stacked book, some form of writing utensil, and maybe a calculator. You might also want to find that yellow perfect roots chart that you have. That might help us today too. Today, our essential question, how do you simplify radicals with and without variables in it? So the title we're going to be in today is this one right here, Simplifying Radicals. That's where you want to open up to. You guys already know how to simplify a radical without a variable, square roots especially. However, we need to talk about cube roots as we're looking at them. So we're going to simplify first the square root of 40. So what we're looking for on our perfect roots chart is we are looking for the biggest perfect square that can go into 40, which we know is 4, right? So we're going to go like this. We're going to say, all right, square root of 4 times the square root of 10 would give us the square root of 40 because you multiply. Square root of 4 is 2. So my official answer is 2 square roots of 10. Notice it's not plus or minus. We're just simplifying. We only get the plus or minus when we are solving. Same process when we're doing a cube root here. The only thing is we need to pay attention to the cube root column. So I'm going to look through the cube root column and I'm going to see which of these numbers is the biggest number that goes into 40. 8, right? Because it would be 27. That doesn't go into 40. And then 64. That's too big than 40. So I'm going to do cube root of 8 times the cube root of 5. Cube root of 8, that's 2. So my official answer would be 2 cube roots of 5. 2 times the cube root of 5 for my final answer. Let's try a couple more. Cube root of 72. So again, I'm looking through that perfect cube column, trying to find a number that goes into 72 easily. 27 doesn't go. It's got to just be 8 again, right? So I'm going to show my breakdown. Cube root of 8 times the cube root of 9, because 9 times 8 is 72, right? Cube root of 8 is 2. So our final answer would be 2 times the cube root of 9. Now we got a fourth root. Fourth root of 512. What's the biggest number that can go into 512? So I'm looking at perfect fourths, right? So 16, 512 divided by 16, that's 32. So that's definitely possible. 81. Nope, that doesn't divide in nice. 250. Oh, 256. Is 256 big enough? It is. I found it. So I'm going to do the fourth root of 256 times the fourth root of 2. And the fourth root of 256 is 4, right? So my final answer, 4 times the fourth root of 2. Now, you may have been like, but Marsh, what if I would have used 16? Well, you could have, right? But then you would have had fourth root of 32, which you would have been like, oh, there's another 16 in 32. Then you could have simplified again. Then you would have still gotten the same answer I did. Now let's take a look with variables. Dun, dun, dun. First thing we're going to do, let's break it into pieces. So I got the fourth root of 625 and the fourth root of x to the fourth. Now, fourth root of 625 simplifies to 5, right? This is 5 because if you look on your perfect roots chart under the perfect fourth powers, it'd be 5. This, fourth root of x to the fourth. Couple of ways to think about this. First thing you can do is you can convert this into the other form, because we talked about a couple of days ago how to change from radical to rational exponent. The only thing is that this is technically x to the fourth to the 1/4 power, because that's what a radical with a 4 outside means, right? Then I would multiply my exponents, which would give me a 1, x to the first. So my official answer is 5x to the first. Another way to look at this, your index tells you how many of each group has to be to get out of the radical. So I need to have groups of 4 to get out of the radical. How many groups of 4 can I make out of 4? 1. There's no one left behind under the radical. Everyone was able to get out of there. So that's another way to look at it. I'll show both ways for a little bit, and then I'm mostly going to talk about the groups. So this one, that 3 is just going to hang out there. I'm going to break it into 2 pieces here. So cube root of 64, that root got a little weird there. There we go. Cube root of 64. Ooh, perfect cube that goes into 64. Oh, 64 is a perfect cube. It's 4, right? So this is just 4. Cube root of y to the 6th. So first thing I'm going to show, if I just change that, that'd be y to the 6th to the 1/3 power. Multiplying my exponents, I'll get y to the 6/3, which is the same as y squared. Okay, another way to look at it, my index is 3. That means to get out of the radical, I need to make groups of 3. How many groups of 3 and 6? 2 groups, nothing left over. Now I just need to multiply my numbers. So I get 12y squared. Kind of confusing with the letters. That's the part that we struggle the most on. Let's try another one. Again, I'm going to break this into pieces. So 5th root of 4, 5th root of a to the 10th, 5th root of b to the 6th. 5th root of 4, he doesn't simplify. He's going to stay like that. 5th root of a to the 10th. So again, I'm going to convert. So that would be to the 1/5 power, right? Multiply my exponents. I would get 10/5, which is the same as a squared. Another way to look at it, to get out of the radical, I need to be in groups of 5. How many groups of 5 and 10? There are 2 of them. Nothing left behind. This one is where the converting takes a little bit of time. So this one, if I change it into my exponents, I'll get that, right? Which is b to the 6/5, which is the same as b to the 1 and 1/5. So what that means is we have one solid b in there, but we still have a 5th root of b. So I could rewrite this as b times b to the 1/5, which would simplify to b times the square root, or 5th root, of b. Confusing, right? Different way to look at it. How many groups of, I need to have groups of 5, right? How many groups of 5 out of 6? There is one group of 5 in 6, but one left behind. So there's going to be one b in the radical yet. Same answer, 2 different ways of thought. I find that a lot of students understand the grouping better than the using radical, changing to radical, thinking through fractions. Then what I got to do is I put everybody on the inside, back on the inside, and everybody on the outside together. So there is a 4 under the radical, so I'm going to go 5th root of 4. A squared's outside the radical. There is a b outside the radical, and then there's a b in the inside. So my official answer, a squared times b times the 5th root of 4b. Okay, let's try the next one. Notice no index, so we're going to put a little 2 there so we don't get confused. I want to break it into 2 pieces. So we got the square root of 40 and the square root of x to the 5th. Break down the square root of 40. That one's an easy one, right? 2 square roots of 10, 2 times the square root of 10. This one, again, I'm going to do the fraction one. So that would be x to the 5 halves if I convert, right? Which is the same as x to the 2 and 1/2, which means I have x squared times x to the 1/2, which means I have x squared times the square root of x. Other ways to look at it. I need groups of 2. How many groups of 2 are in 5? There are 2 of them, and I have 1 x left behind. So this guy shows you how many groups you took out. Now, just put your outside people together and inside people together. Let's try another one. So we're going to simplify all of them. I'm going to break it into pieces. So cube root of 1/8, cube root of y to the 9th, or x to the 9th, excuse me, and cube root of y to the 7th. Cube root of 1/8, I need to distribute to the top and the bottom. Cube root of 1 over cube root of 8. Cube root of 1 is just 1. Cube root of 8 is 2, so that's 1/2. Cube root of x to the 9th, this means I need groups of 3. How many groups of 3 are in 9? There are 3. None left behind. Again here, I need groups of 3. How many groups of 3 in 7? There are 2 groups of 3, making a total of 6. But there's 1 y that didn't get out. So our official answer would be 1/2 x to the 3rd y squared times the cube root, didn't write the cube root, of y. Go ahead and try this one. See if you can get the answer. So pause the video, double check it, check my work after you're done, just to see if you can get your answer correctly. Okay, you should have paused. So now I'm going to break it into pieces. That 4x is just going to hang out there. This is a square root, right? So square root of 169, square root of x cubed, square root of y to the 4th. So square root of 169 is 13. Groups of 2, there are 1 group of 2 in 3 and a single x left behind. There are 2 groups in 4, none left behind. Rewrite my answer. There's my answer. Oh, just kidding. It's not my answer. Guess what, guys? Marsh missed something. I forgot about that 4x. Silly, silly Marsh. So we're going to need to multiply 13 times 4. Let me grab my calculator quick. 13 times 4 is 52. So I'll have 52. Combine these x's. I would get x squared, y squared, square root of x. That's the official answer. Whew, almost messed up there. Last question here, I think. Yep. So we have the 5th root of all of this information. When I have a radical on top of a fraction, I can break it into 2 little radicals because technically this is this problem, right? In which we would give the 5th to everybody. So if that makes more sense to your brain, go ahead and rewrite it. But I'm just going to break it into this. Just like that. Okay. 5th root of 243 is 3. So that denominator is just a big 3, right? Now, this numerator, I need to do a little bit of work on. So I need the 5th root of 32, the 5th root of x, and the 5th root of y to the 5th. 5th root of 32 is just a 2, right? 5th root of x, he doesn't simplify, so I'm just going to rewrite him so I don't lose him this time. 5th root of y to the 5th, so I need groups of 5 to get out of the radical. There is one group of 5 and 5 with no one left behind. So I'm just going to rewrite my problem. There we go. And that is my numerator. There we go. That is the end of this video. I know simplifying radicals is kind of a little different, especially with those letters. So we're going to have to be very careful with that as we're looking at it. And dealing with how many groups, or if you're like those fractions, that would be another way to look at it. Until the next video, I'll see you later, Sabers.